Centuries of spaceflight has uncovered less than 1% of star systems inhabiting the known galaxies, a statistic that has only fueled the thirst for exploration. In this season of An Interloper's Guide, we will reveal some of the newest discoveries made by our community members, exploring the relationships between planetary environments and their native species. Welcome to An Interloper's Guide to Uncharted Worlds, Episode 1, the Damadurma XII System. Residing within the Seawall Spur region of the Euclid Galaxy, Damadurma XII star supports 4 planets and 1 moon. Until recently, the system remained uncharted, and it currently possesses no space station or interloper settlements. Its discovery has sparked great interest within scientific circles, owing to the incredibly rare lifeforms found inhabiting its varied planets. Maintaining the closest orbit to Damadurma's star is the volcanic planet Loftusan XVI. Loftusan's path around the system's star is elliptical in shape, an orbit that causes the planet's internal temperature to skyrocket, and deformations within its crust to form. As a result, each loop around the star heightens geothermal activity on the planet, resulting in the birth of many active volcanoes on its surface. These volcanoes dominate Loftusan's landscape, their regular eruptions raising atmospheric temperatures to well above 200 degrees Celsius. Bizarre volcanic rocks formed during intense lava flows litter the scorched landscape like ancient monuments. An almost constant ashfall distributes rich nutrients into the soil, making fertile ground for sparse patches of vegetation and trees to take root. Aside from these plants, Loftusan XVI's ecosystem is exclusively synthetic in nature. This is Fonazprocis, the planet's most common synthetic lifeform. They wander serenely across Loftusan's surface, carried by 4 mechanical legs. Adorning the Fonazprocis' back, an array of radar dishes map the area as it passes through, noting recent changes in the landscape. This information is collated in the creature's processing center, before being broadcast planet-wide to other members of the Fonazprocis species. The signal is so strong that our crew picked it up on the ship's transmitter before we even breached the planet's outer atmosphere. With the combined scanner readings from Fonazprocis positioned all across Loftusan, each member of the species possesses a flawless map of the planet's ever-changing landscape. This allows members of the species to safely navigate the planet's volatile environment, avoiding hazardous areas such as newly formed ravines. As well as benefiting the Fonazprocis themselves, other synthetic lifeforms on the planet can also access this frequency, extracting information about their local area that is vital to survival. One such creature is the Grasepproe. These 4-legged lifeforms are small in stature and are easily identifiable by the industrial filters protruding from their backs. They travel in small herds searching for a specific geological phenomenon, an endeavour made easy by the constantly updating navigational data provided by the Fonazprocis. The object of their search, biolite, also known as lava stones. These curious formations can be discovered all across Loftusan's surface. their immense size dwarfing the planet's creatures. Grasepproe filter gaseous hydrogen sulfide molecules emitted from these lava stones for use in energy production. The species are capable of generating enough power to support not only the individual Grasepproe, but the entire synthetic ecosystem, with the help of the planet's final biomechanical creature. This is Bloonglium, the planet's largest and rarest synthetic lifeform. It moves slowly across the volcanic plains, its large, round body supported by 4 mechanical legs. Each Bloonglium occupies a single expansive territory, and between them, the species leaves no area of the planet unpatrolled. Their presence is vital to the continued survival of all synthetic lifeforms on Loftusan, owing to their unique ability to store large quantities of energy. Grasepproe transfer any excess energy they generate to Bloonglium, allowing the larger species to store it in specialized batteries located on their backs. This stored energy can be distributed to any of the planet's 3 synthetic species, a process particularly useful in areas experiencing an energy drought. Despite Loftusan's hostile environment, the planet's synthetic ecosystem exists harmoniously, each species reliant on each other for their survival. Fonazprocis provides navigational data, identifying hazards and energy sources for the Grasepproe. The Bloonglium then stores the collected energy for use by all species on the planet. With each species fulfilling specific roles, synthetic life is thriving here. However, Loftusan XVI is not the only planet within Damadurma XII that supports biomechanical life. This is Motho Major, the system's desert planet. During the day, heat from Damadurma's star radiates from the planet's sandy soil, helping to maintain atmospheric temperatures of around 15 degrees Celsius. As the night draws in, any remaining heat trapped in the sand dissipates, causing a rapid temperature drop of approximately 75 degrees. Small lakes indicate the presence of subterranean rivers, their water collected by the deep roots of the local flora. Only the hardiest of plants can survive the planet's drastic fluctuations in temperature, including various cacti, small flowering plants, and some species of tree. Like Loftusan XVI, Motho Major is populated by an array of entirely synthetic creatures. This is Graintwia, the Damadurma system's largest biomechanical lifeform. Reaching heights of just under 8 meters, the species dominates Motho Major's dusty plains and are often found roaming the planet in small, tight-knit groups. Unlike Loftusan's creatures, Graintwia are completely self-sufficient, equipped with all the amenities essential to their survival. Black solar panels located on top of the creature's body absorb energy from Damadurma's star, storing it in large internal batteries. Highly specialized sensors track the movement of the star across Motho Major's sky, helping the Graintwia to plot the best route for energy absorption each day. Being the largest of the planet's creatures, Graintwia are at a particular risk of damage during planetary dust storms, their large surface area a target to lightning and flying debris. As the gale force winds subside, an internal systems check is performed, identifying any malfunction or tears. Graintwia unlucky enough to be mortally damaged in the storm are preyed upon by others of their species, their parts ripped from their bodies for repairs for the more fortunate. The self-sufficiency displayed by Graintwia appears to be a common theme within Motho Major's ecosystem. This is the planet's second largest creature, Magnetobirrum. The species are highly intelligent, capable of operating independently from others of their species, a trait rare in synthetic lifeforms. Each individual forges their own path across the planet's hazy plains, and they possess no social hierarchy to speak of. Magnetobirrum's pink and yellow rounded body is encased in an intricate golden cage, a feature that serves a dual purpose. Their internal hardware contains delicate components that are highly vulnerable to electrical surges. Given their size, Magnetobirrum are also a target for lightning strikes, an event that would be devastating without the protection of their highly conductive cage. Its protective qualities function the same as a Faraday cage, with one notable difference. Rather than dissipating the electrical energy entirely, it directs it into batteries within the creature's body, whilst protecting its sensitive components from direct contact with the electrical surge. As well as being utilised for lightning deflection and energy reduction, Magnetobirrum's cage further shields the creature against flying debris caught in the high winds. Other inhabitants of Motho Major, however, are not as well adapted to dealing with the planet's devastating storms. Photowicica and Taloseotea are the smallest of the planet's synthetic creatures. The species are often found together, roaming the desert in large intermingled herds. Their small size would make a single lightning strike fatal, and they must seek shelter whenever a storm hits. Photowicica's plating is dark purple and blue, adorned with a series of spikes on its shoulders. These spikes serve as highly advanced barometers, capable of tracking atmospheric pressure changes within a 200-mile radius. This technology allows them to detect incoming storms, giving the Photowicica plenty of time to seek refuge within the planet's extensive cave systems before they hit. Taloseotea, identifiable by its rounded backplate, benefit from their close proximity to Photowicica. They follow the Photowicica underground, knowing their retreat to be an indication of an imminent storm. Both species will remain here in the safety of the caves, only emerging once the weather clears. Seemingly perfectly adapted to the harsh conditions of both Motho Major and Loftusan XVI, synthetic life is thriving within Damadurma XII. On the system's moon, however, it is biological life that triumphs in the face of environmental adversity. Oklahak Gamma is a tectonic moon that orbits the planet Jacqu Beta. Its arid landscape is scarred with both active and dormant volcanoes, formed over millennia by the movement of the planet's tectonic plates. Temperatures here barely fluctuate, maintaining approximately 65 degrees Celsius throughout the day and night. Oklahak Gamma's scorched ground is made up of fine particles prone to ignition, causing small fires to sporadically break out across the plains. Despite this hostile environment, the planet supports a busy ecosystem, comprising a diverse variety of grazing animals. With vegetation being relatively sparse, competition between species is high, and adaptations for ease of travel are favoured amongst the population. Oklahak gamma soil made rich by the volcanic ashfall supports tall lush Mossosa trees, their sap weeping from their bark. The sap itself possesses fire retardant properties, and as it slowly travels down the trunk, it forms a protective layer. Superheated embers from distant fires blow in the wind, and lush Mossosa's adaptation offers resistance against its bark going up in flames. The Photowicica plant, recognisable by its vibrant red stigma and woody stem, has developed a different method to survive the planet's sporadic fires. A large majority of this plant is hidden underground, interconnected to others of its species by a vast mycelium-like network. Should the flowering part perish, in time a new one will take its place, aided by the subterranean network of nutrients and information. Of all plants on Oklahak Gamma, there is one species that has piqued the interest of many scientists due to its unusual adaptations. This is Tempodopima, an incredibly rare plant species that possesses animalistic qualities. Weaving vines compose its body and legs, and it moves freely across the planet's ashy plains, unrooted to any particular spot. This adaptation is believed to assist the creature during firestorms, allowing it to sidestep any burning ground. The vines also help to disguise the creature's bulky outline, the gaps in its body, coupled with its brown-green coloration, further aiding their camouflage. This is key to the Tempodopima's survival, as living amongst an exclusively herbivorous ecosystem, they are a favourite target for grazers. Lining its back, a vibrant arrangement of red and yellow leaves, photosynthesized in the light of Damadurma star, providing the Tempodopima's energy. Heavily perfumed pink flowers adorn its face, attracting insects for pollination between members of its species. Details of their full life cycle are currently unknown, however speculation suggests that Tempodopima bury their fertilized seeds, keeping them safe underground until they are fully developed and mobile. Loftusan, Motho Major, and Oklahak Gamma comprise the youngest ecosystems within Damadurma XII, the fossil record showing the first signs of life appearing within the last few centuries. The system's other planets, however, possess a history dating back millennia. Omas XI's orbit is the furthest from Damadurma's star, resulting in a perpetual ice age. Its rolling hills are covered in a thick permafrost, the frozen soil supporting very little vegetation. A majority of Omas's sparse animal populations have evolved a rounded body, opting to roll across the freezing terrain. This mode of travel allows the species to easily navigate the frigid, hilly landscape in search of food. Supporting the oldest and most diverse ecosystem within Damadurma XII is Jacqu Beta, the gamma-intensive planet orbited by Oklahak Gamma. The plants and creatures here have adapted to thrive in Jacqu Beta's extremely radioactive environment, enduring its frequent ionizing storms. Despite their adaptations, the molecular chemistry of biological life is constantly changing here, resulting in various mutations tracked through the planet's extensive fossil records. Damadurma's planets perfectly illustrate the sheer variety of life just waiting to be discovered within the universe. From the plethora of synthetic lifeforms inhabiting Loftusan and Motho Major to the Tempodopima on Oklahak Gamma, we have discovered that life constitutes more than just biological entities. If you have made it this far, thank you for watching, and as always, have fun, stay safe, and be curious. Uncharted worlds, untouched by outside influences for millennia, offer valuable insight into the natural evolution of ecosystems, as well as breathtaking, unspoiled vistas. If you would like to join the hunt and have your discoveries featured on an episode, join our Deep Space Tribe on Discord, or leave us a comment here.